Hi, my name is Adam Ress, and this is my Lab 3 Physics 2212 presentation. So, introduction. The purpose of this lab was to apply charge and energy conservation to predict and measure currents and potential differences in simple DC circuits, and to examine the time-dependent behavior of resistors and capacitors in an RC circuit. So, the results. So, experiment 1, we were able to prove the loop rule from our multimeter measurements, and then for experiment 2, we actually had a slight inaccuracy in measuring the charge and discharge times. So here are some fundamental principles for this lab. So the loop rule, which is that in any closed circuit loop, the sum of all voltage rises and drops is 0. The node rule, at any node, the sum of the currents is 0. So as you can see in the picture, the node between I1, I2, and I3, so then we would know that I1 plus I2 equals I3. Then there's Ohm's law, which famously describes the relationship between current, resistance, and voltage. V equals IR, which can be transformed to be I equals V over R, etc. So now for the experiment. So experiment 1, so we had two resistors in series with a DC source, which was the battery, and then we had the battery and lab environment, which were the surroundings, and the components were two 1.5 volt batteries and two resistors, 47 and 100 ohms. And here's a diagram of what it looked like. So here are the results of the experiment. So we measured the current of I1 from our ammeter to be 19.8 amps, and then I2 to be 20 amps. And then if we look at the decrease in potential between different parts of the circuit at different times, so we see from C to D, we lost about 0.9 volts, then from D to E, 1.6 millivolts, E to F, 2 volts, F to G, 7.6 millivolts, and then G to H, we didn't lose any volts. But you can see we expect it to go back down to 0 because that would prove that the loop rule means that there is no rise or decrease in voltage in the end. But we actually got 0.05 volts, but that can be due to many different errors, such as human error and measurement error. So experiment 2 was a setup where we had a battery bulb capacitor in series for the charge, and then we got rid of the battery and then just had the capacitor just discharged with the bulb. So the components were two 1.5 volt batteries, one 1F capacitor, and then one light bulb, which acts, which is a resistor. But when we see the heat glow when the electricity is traveling through it. So there's also a diagram of the circuit looks like, and then a picture of our setup in the lab. Oops. So predictions and outcomes. So the predictions was that it would take about 12 seconds to charge and discharge, which we calculated with the formula that we multiply the resistance by the capacitance. But the actual measured data that we got was that the charge time was 20 seconds and the discharge time was 21 seconds. So some sources of error for that is human error, again, in measurement and experiment. But also there's resistance in other things such as the wires, battery, or even the capacitor. So for the discussion, so what if you charge the capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. Use an ammeter to measure how long it takes to charge the capacitor when connect directly to the battery and the ammeter. Discuss why the measured time is different from the predicted time. So ideally with no resistor, the capacitor would charge instantly because the model allows an infinite current. In reality, though, there is always some resistance in the battery, the wires, and the meter, so the charge happens very fast, but it is not instant. When you try it with an ammeter, you will measure a short non-zero time because the meter and internal resistances limit and spread out the current. So in conclusion, Kirchhoff's and Ohm's laws turn really messy and complicated circuits into something that is predictable and testable. And then by choosing R and C, we set currents, voltages, and timing to meet our goals, which is very useful. And thank you for listening to my presentation.